Hey guys, welcome back to the channel. This is will be part two on the 2006 Moomba Outback from Jim in Illinois. I contacted him and I explained that the problem is indeed on the other side of the board, and he's eager to spend the money on buying another computer because he's worried about it might damage the new computer because this looks like a brand new computer. And he got the boat like this, so I said, you know what, let me remove the complete board out. So I'm going to take the time to help you and try to dissect and find the problem. So as you see right there on the bench, I have the board completely out, and I was able to completely remove it without damaging the board. Uh, a little mine, like very small uh, damage in here, which realistically is not really a damage, and you can see here. This is just a heat sink. It's a ground pad heat sink in order to dissipate heat. All these are voltage regulators and some motor components. It can be part of drivers. Again, no marking or anything to find out what it is. We got the microprocessor in here, crystal oscillators, and voltage regulating area on this side, since we have the coils, inductors on this side. This is the actual um, case, as you see. Let me put this, let me put the microscope camera on so we can all see this. I'm going to set you guys shortly in the bench, and I'm going to do a few tests and show you what the actual problem is, which I already know. But I want to at least show you a little bit closer uh, how this looks. So we have, let me put this on microscope. Can I do a screen recording? Because if I do a screen recording and I move it into microscope, I will probably not record that, right? I don't remember that. Um, because it's either or. I think let me just make this full screen, like that we can see that better closer. Um, you guys, let me just move this a little because you're in the tripod right now, so I'm trying to get you the best view possible. So right now you're looking at here. So as you see, when I move that, it moves it in here. So one thing that I want to show you is, because this is the best way to see this, so we can see the coloration. So you see how this is kind of like green, a light green, but that is kind of like yellow. That is no good. If we see the other two, these are the same color. So looking at this way, now let me just put this in this perspective. So we will have, um, right now, these two are the same color as this one, but not this one. So these four should be around the same color, and these two the same color. That's why we got this thermal paste in here to dissipate the temperature and prevent a short due to overheating. So if I move like right there, you see how these two are a completely different color. These two are around the same color, and these two are the same color. So we have a problem, and um, what I find is that, well, we no communication, nothing is working on this computer, nothing is coming on. I already checked, and we have a short. Oh, the other thing that I wanted to show you before I proceed with that is how this looks. Let me focus the camera a little better and get a little view so you guys can see that indeed everything was desoldered. Sorry for the wrong angle. I'm trying to show you, but yeah, you can see that everything was desoldered properly. No damage in here, nothing. All the connectors look pristine. I don't see any damage, no burns. This is what you guys are seeing on there. I'm gonna get you a close look in here, and then again the thermal paste. This is also for Jim to see that this is indeed his computer. This also has two other pads that are just a ground, again, for heat dissipation and to keep the board in place. that this will be like this, right? Because I'm right now showing you the underside of the board, and this is like this, right? So, sorry, like this. But yeah, you can see that all the holes are now, you can see through. Everything came out perfectly, so no damage to the board, and you can remove it. It's not a simple task to do, but it's possible. All right, so let me get this out of here, and I want to put the board here, and I want to do a few tests with you, so you guys can see what is in at the end. The main problem this board has. I'm going to have to set you somewhere around there. And I'm just going to get my multimeter. I can get this out of here. Hopefully you can hear the beep. Yes, and I think it's being picked up by the microphone. All right, so that's when I connect the leads together, we got the continuity test. So things that I don't like is, well, these are diodes all here, and this is the main ground path in here, and here we got continuity. So you can hear that beeping, and so it's in here, and so it's in here. Uh, Maybe not on that one, let me see. But yeah, that's not continuity to ground. Oh yeah, no, that's completely separate, so disregard what I said on that one. But these are grounded, and I can see that on the other side of the board, because this is touching, that one is not touching. But yeah, those are just ground pads. Hopefully you guys still can see good. All right, so but what I want to show you is, let me get the microphone, I mean the microscope, what I can see. We have a little bit of a burn spot in here, so I tried to remove this diode. And let me put this in focus on the camera so you guys will be able to see that. I'm going to show you the screen in 1 second. So I'm sorry for the moving back and forth. But yeah, so you can see this section right here. It's still not open, but it's definitely, you can see the clear coat or the protection being removed. I just move it out with like this step. And I try to remove this because this is shorted to ground. So let me get you back into a good position. I don't want the camera to fall. I think that should be okay. So it is normal for one side of a diode to show continuity to ground. Again, I'm touching it here. So this, if you have a ground on one side, then it should be no ground on the other side. But if I touch in here, come on, trying to clean these up. So we got continuity there. If I touch here, you see it's continuity. It's showing 128 ohms. Not sure if you guys can see the meter in there. I think you do. Let me move this here. Sometimes I try to make it better and it's not the best, but so if I show here, if I touch in here, we get continuity, but it's not fully shorted, but we got 128 ohms. Remember that measurement, because that's exactly what we got on the other side as well. So it should be no continuity, right? So if I check this order, there is no continuity, open line. Same thing in here, and same thing in here. So this one's showing a measurement 608, so that is partially, but it's not beeping, so it's not enough to show us continuity. But if I measure from here to here, it's dead short to ground, so that's the ground side. If I measure on this other side, it's 127 ohms. So it's still not fully shorted, but it's shorted. If I touch, let's say this one here, that is a direct short. If I touch the other side, it's a direct short. See, this one is a direct short to ground. 0, 0. So these are direct short. This should not be at the direct path. We have continuity in there. That's the way this should look, what should be. Like when I touch in here, we should have continuity, and this is the ground pad side. All these is grounds in here, right? So let me just make sure I'm touching. Yeah, ground, 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 ground. So you can see that all these sides on these are capacitors, is ground. The other side should not be. So we got a direct short in there, nothing in there. I'm just going to keep touching around because I remember finding multiples. You see, we got another one showing 0 and 3, and then here and here. You see, so all this area is shorted. So this area is under this exact IC. That's a 5-volt regulator. So now, again, the same area that we were having the direct short to ground. The next thing that I did to find out what's going on is I went over to let me put this on the microscope. Let me just give me 1 second, guys. So I'm just setting up the microscope so we can see that later. I'm just, setting that in there so we have the view. But so the next thing that I did, let me escape this view, is I selected this two. So we got 5 references. So I want to go into J. Let me see. Well, actually, we have it here. So J1, connector J1. J1. So right now, if I move or not move, if I get this right here, that blue connector on the left side of the screen is J1, the middle is J2, and the right side is J3. That's exactly as we have now the board in there. So this is J1, J2, and J3 because it's flipped, right? So this is like having the computer exactly as it's supposed to. So if I go here, it shows me that J132 right there is a 5-volt reference for the vehicle speed signal, and then the J133 is a 5-volt reference for the pedal position sensor 1. So I'm going to then find those pins, looking at the connector, sorry again, it will be 1 to the third row, pins 4 and 5, right? And that's how I find it. So if I go there, so first row, second row, third row, 4 and 5. Looking in the microscope, I can see the 32 and 35, sorry, 32 and 33 are actually together here. And I can see that here. You see how they beep together? So they are together. So I'm going to just put one of my leads in here. And now I'm going to go over to that regulator. And I'm going to go here. And that's the 5-volt regulator. You see that's a direct pad. You guys are seeing them. Yep, you can see the meter reading 0 as soon as I touch in there. So that's how I know that this is the 5-volt regulator. I don't need to do anything else. This is not even replaceable. It's a crystal driver, not replaceable. This computer is garbage. The other thing that remember what I told you about 120 ohm reading, you're good in there too, is this coil. If I measure this coil here to, let's say, here, looking at the meter, you see that 127? That was the reading that we have in the other side. So this coil, 127, is completely shorted. Not the coil, the actual 5-volt regulator is completely shorted. If I measure the other coils in here, that's an open line, sorry, open line, and open. This one, open line, I'm trying to touch good, open line, open, and open. So this coil and the 5-volt regulator are shorted to ground. And this one is, that's why we have like 127 ohms, because if I measure the resistance on these coils are very low, 2, 3 ohms, 6 ohms. That's, sorry, zero point 0.3 of an ohm. So this is like no resistance. Those are the way just these inductors are. But so the problem is right there on this crystal driver. So again, this is just a conclusion to show him that I definitely took the time, and also you guys, that I take the time to try to help the customer and solve the problem that he might have. So my resolution with this computer is that one of the sensors was shorted to power. This is now a direct short to ground. The way that this happens is if a 5-volt reference a sensor gets shorted to power, it will cook the not the microprocessor, sorry, the voltage regulator, and then it will create this short that we have. If this would be an IC like this, I would have been able to replace that driver or 5-volt regulator and then fix this computer. The problem is by being these type of drivers, or again, I keep saying driver, not driver, IC, it's a crystal IC. I cannot, there is no part number. Again, this is exactly where you're going to just move my finger in there so you can see that that is indeed that one right there. And as you can see, it's a crystal driver, or sorry guys, crystal IC. They do this in purpose, so it's one-time use, no repair on that one. So sorry, Jim, but yeah, this computer cannot be repaired. This is as much as I can go and try to help you locate the issues in the boat. I definitely think it's a short to power on one of the sensors or in the harness. Remember, it can be the throttle actuator, which is a common either the throttle actuator or let me pause the video 1 second, guys. All right, so what I was saying is the throttle actuator, or let me escape this. We don't need this no more. Um, Sensors, they do have, you know, a 5-volt reference and a sensor ground, and you can short in the harness. If it's short in the harness, they will get shorted. You can short a 5-volt reference to um, uh, 12 volts, but they're usually not that close together. So you can short to ground a 5-volt reference, and that, can create a problem. Usually the 5-volt reference and the signals are protected enough that if a sensor is shorted, it can, make the boat stall or something, but it will definitely still try to run unless it's one of the main inputs like a crank sensor signal, but it will give you a fault. But usually you got a shorter sensor, you change the sensor and the boat runs again, doesn't really burn the computer. But when you inject 12 volts, that is catastrophic for the computer. So the throttle actuator, that's the connector. Give me 1 second. Sensors, injectors, throttle. The throttle actuator or the throttle body, right, is one of the ones that can actually become a problem because if we see here, we got the throttle motor, right? That's the one it will open the flap, and that's 12 volts. So the computer controls completely the movement of that actuator going even open or close by changing the polarity, but it's definitely at 12 volts because that draws a lot of amperage, like sometimes up to 2 amps, and even more depends if it gets stuck. But in the same electronic throttle body, we have a 5-volt reference and sensor signals. So if this gets water intrusion or something like that, and it can short at 12 volts to the sensor signals or the 5-volt reference. So I will start with that one. It's a very, very prone area. And if it's not the case, I will then go over with vibration and heat. Try to look into your harness close to areas close to the, again, vibration, anything that it vibrates so much. I mean, in a boat, there's a lot of areas, but remember, when I'm talking about vibration and heat, you try to go into areas of the harness where it gets a curve and is attached close to the motor, because that will vibrate. And if it's a clamp or something like that, it can cut the harness and then produce a problem like that. Heat, muffler, exhaust manifolds, etc. Right? All right, guys. Thank you so much for visiting the channel. I hope that you all like this content and the time that I put together on this, trying to help not just Jim, others with situations like this. I explain Jim how I will proceed to check the harness. I will first start with a multimeter and continuity. You want to do is like a check like this. I'm just going to do something simple here, so give me 1 second. Continuity test, you put your meter in continuity. If you touch and this wire is good, it should beep. Well, if I put the beep, right? And that shows me how much the resistance is. But this is not 100% bulletproof. So if you're checking your harness, let's say you are on the throttle body connector. We are on this Pincy, and then on the J229 at the computer, with the computer disconnected, with the throttle body disconnected. This is the harness on the boat. So throttle body side, computer side, like just to say something like that. The first test that I will do is this, to know that I am indeed in the correct wire. Okay, so that's test. This is called wire integrity. The next test that you want to do to make sure that this wire is also good is you're going to leave your meter connected onto one end, now that you know that you are in the right wire, and you're going to touch battery negative or a ground on the block, and then you're going to do all these tests with the battery disconnected, the positive side, and you're going to touch also no continuity to ground, perfect. You're going to touch now this lead onto the battery positive cable, not the battery positive terminal, the battery positive cable. If it's any continuity, that means that this wire is shorted to a power somewhere in the harness. This happens, if it let's keep going the correct way. If that doesn't happen, this wire still can be halfway open and it will show continuity. Why do I say that? Because let's say, on a wire like this is usually 22 strands, so you have not just one solid wire, you have multiple little wires that will connect end to end. If even one of those wires is still there, it will show continuity. So the wire will not carry amperage, will not be enough to work, but it will show continuity. So the next test you want to do is you're going to, on this side or either side, right, with the wire disconnected from the computer and from the throttle body. Let's keep the word checking the wire, right? I'm going to connect this side with a wire, fuse wire, even though I already know that there is no short to ground or short to power, right? But I'm going to put a fuse just to be on the safe side. So I'm going to have a fuse wire to ground. And now I'm going to use my test light connected to battery positive, and I'm going to touch here. If my light lights up nice and bright, that means this wire is able to carry a load. I would recommend, depends on what you're checking. A sensor wire, you can use a test light, a regular test light, because that's not meant to carry a lot of amperage. But if I am checking, then let's say, J212, which is one of the main wires for that motor, that is meant to carry 2-3 amps. I'm going to use a bigger test light. I can use a test light is something like this, right? These bulbs, they um, draw around 230 milliamps, but you can change the bulb and increase the amp draw. Let me see if I find that one. Yes, like I have these bulbs that fit in the same exact test light, and if this one will draw almost 2 amps. So depends on what I'm checking, I'm going to change the load. Again, a bulb. You can use anything, right? That it's a load. You can use I have seen guys even using a fan motor, a small fan motor, those little motors, and they draw 2 amps, 2.5 amps, 3 amps, whatever. Even a halogen bulb, depending on the wire that you are checking. Remember, this is with everything disconnected, no ECM, no throttle body. All you're checking is the harness. Then now you know that this wire is good. You can then move to the next one. If when you're doing the continuity test, you have a short to ground or short to power, then that's where you're going to again keep the battery disconnected and you're going to supply a power, or let's say you have a short to ground on this wire. So what I do is I'm going to connect here my test light, and the test light will be connected to battery positive. It's going to light up because this is shorted to ground. I don't know what is shorted, right? But I know that it's shorted to ground. So as soon as I plug that in, that test light lights up. And then now what I'm going to do is I'm going to start wiggling the harness with that test light connected and light up. It's going to be nice and bright. And then when I'm moving my harness, that test light goes dim, or it was dim, and then I move it and now it's actually brighter. Oh, let's focus into that area. Let's see if you have a hose clamp or a clamp holding the harness that is a metal or is rubbing into the engine block or something, and then try to find, because definitely the short is around that location. You're going to open carefully the harness and look for the wire and see if it is wire is shorted to a ground in there and the block, or if it's actually heat and it's melted and it's now you have a portion of the harness shorted together. And that's how you find a short to ground. When you have, sorry, a short to power is a little more difficult, let's say, to do, because you have to be more careful because it's actually power. But what you do is then you connect the battery and you're going to put the test light to ground, right? And now the test light is going to light up because that wire, either wire there is now shorted to power. It's going to be either dim or very bright if it's completely shorted to ground. It's not going to melt because, sorry, to power. It's not going to melt because now this is disconnected on this end, right? So we can remove the computer, remove the electronic throttle body. You don't have to connect any of that. So all you have to connect is the battery, right? And then you start wiggling the harness and do the same test. When the test light goes off, now you know where the area is of that short, and that's what you want to do. And that's wire integrity test. I always recommend, and I told this to Jim, if I'm doing a test for all the fiber references to see if they're shorted to power or to ground, I take a notepad and I go wire integrity test, wire J11, J12, J13, whatever the fiber references are, and I put pass, 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 didn't pass. Or if they all pass, I go and I own all the injectors to make sure first that injectors are not shorted, and I'm 8 injectors, what the reading of each injector are like that. If me or somebody else need that information later, because if I ask Jim, yes, I own all the injectors and they were all around 12 ohms. Okay, so are you 100% sure 12 ohms? Yeah, I think I remember it was 12 ohms. Remember thinking that can lead to errors. If you write it down and you have in your notepad and you tell me, oh no, Mike, I measured it, one was 2 ohms, three, four, five, six, seven, eight, nine, and 10, or eight, whatever, they were all 12. Okay, we have a problem in one. Let's focus into that injector. Let's now remove the harness and see if it's any short to harness. Do the wire integrity, but you got results that you can revisit and then help a technician like me or another technician help you locate and fix the problem in the boat, in the vehicle, and anything that you're working on. All right, guys, thank you so much for visiting the channel. I hope that you all understand how much information I'm trying to share with this conversations, with all these tests and all these disassembling and everything. Again, don't forget to subscribe. Happy New Year. Happy 2024. I wish you the best. God bless you, and I hope that all your goals become true this year. Stay tuned. Thank you so much. Bye bye.